this then. So in 5.5, what we're going to do is we're going to graph rational functions. In 5.4 that we did last class, we didn't do that. We just kind of talked about the preliminary stuff. So I'm going to run through that today. Some of this at the beginning is just going to be some review here. So what we're working on is rational functions. Rational functions are ratios of polynomials. Okay, so the numerator is a polynomial, denominator is a polynomial. Okay, so let's see, a vertical asymptote occurs when the, and really it's good to write this on here. I should have put this on here. When the reduced form, the denominator is equal to 0. Sometimes you'll have a rational expression and you want to cancel something out. And we'll see a couple of examples like that, so I'll kind of talk about that when we get to that. So a vertical asymptote occurs where the denominator is 0. Okay, so in this case, and a lot of times you can do that in your head, so you set the denominator equal to 0, you get x is equal to 4 like that. Okay, now I want to show you this. You don't need to do this on your calculator. We're going to do plenty of things on our calculator. Just a minute, let me clear all this stuff off from calculus this morning. So if I was to put in 1 divided by x minus 4, this is kind of, we didn't really do any graphing last time, we just talked about this. So if I just did this in a standard window, what you'll find that happens on this problem is on a vertical asymptote, notice at 4 you're undefined. So you have a break in the graph. So whenever you have a vertical asymptote, the graph's going to either go that way or it's going to go that way. It always will. So you're either going to break and both sides will go to infinity, both will go to negative infinity, or 1 to 1 and 1 to the other one. So that's what's always possible on that, is you have that. Okay, so one thing I'd like you to do on this is just kind of make like a real rough sketch. All I really want on here is just go to 1, 2, 3, 4, put a vertical asymptote like that, x equals 4, and then just do a very rough sketch. It doesn't have to be perfect. What I want to make sure that you know is that this is going to infinity and going to negative infinity. That's the way asymptotes behave, okay? All right, so we talked about that, and you probably should have done a little bit of that on your homework, okay? And the next thing is the horizontal asymptotes. You should have done a bit of this on your homework also. So what happens on a horizontal asymptote is if the degree of the numerator is less than the degree of the denominator, then y equals 0 is a horizontal asymptote. Let me have you write down just one example of this, and I'll just kind of review this on the graphing calculator. So let's say you have something like x over x squared minus 1. Okay, now I'm going to put this in the calculator. You don't need to unless you want to, but I want to show you kind of what happens on this. So I'm going to put in x and then divided by x squared minus 1. Now let me ask you a couple of questions on this, all right? So first of all, where is this function undefined? Just in your head. 1 and where else? There's 2 places. Negative 1, right? Okay, so you'll have vertical asymptotes at 1 and negative 1, okay? But what happens is the degree of the top is 1. Remember, degree is the highest exponent. Degree of bottom is 2. So that means the graph is going to level off at y equals 0. So you already know that by looking at this. Part of what you're doing, if you're going to go like to calculus and take classes like that, you want to be able to know certain things about functions pretty quickly. So what I'm seeing on this is I'm seeing an asymptote at negative 1 and one at negative 1. But then a horizontal asymptote just tells you what happens when the graph goes to infinity. So it's leveling off at 0, right? These y values are leveling off at 0 in both directions. Does that make sense to you? Okay, so that's what a horizontal asymptote does. Okay, let me give you an example of this case number 2 here. Okay, so let's say you have, just write down this example. Let's say that we have f of x equals 2x minus 1 over x plus 2. Okay, what's the degree of the top on this problem? 1. What's the degree of the bottom? 1. So if they're the same, if the degree of the numerator and denominator are the same, the answer is the leading coefficients ratio. So what you would end up getting on this one is this. Your answer is right there. So your horizontal asymptote would be y equals 2. Okay, now let me show you what happens on this one on the calculator also. So if I put this in, I'd have to put in the numerator in parentheses like this. That would have to go like that. Then divide by parentheses x plus 2. All right. So let me ask you a question on this. Where do you think there's a vertical asymptote on that problem? There's one vertical asymptote. Where do you think? -2, right. Okay, the function's undefined at -2. Now the horizontal asymptote's y equals 2. So if I graph this, you know, this is kind of what you want to know is, okay, we're going to have a break at -2, like that, because that's your vertical asymptote. But this thing is leveling off at 2. So what's happening is x gets bigger, the y value is getting closer to 2. So that's what's happening on a horizontal asymptote. Does that make sense to everybody? Further out you go, the closer that the y value gets to 2. That's what a horizontal asymptote is showing them, okay? All right, we went over this stuff kind of last time. So the other thing is, if you had something like this, write down this example. Say you had f of x equals, let's say something simple like x squared minus 1 over x. Okay, the degree of the numerator is 2 in this example, and the degree of the denominator is 1. So if that's the case, then you don't have a horizontal asymptote. So let me show you what would happen in this problem, okay? And again, you want to be able to kind of reason out pretty quickly what the asymptotes are, and then that'll help you quite a bit. So let's see, I got to put in the numerator in parentheses, so I put in, let's see, x squared minus 1, and then I divide by x, okay? Where is this function undefined, the one that you wrote down? 0, right? So you have a vertical asymptote as x equals 0. Now what you're going to see on this when I put this in is you're going to see everything kind of slanting. So what's going to happen, anytime the degree of the top is 1 bigger than the bottom, it's going to be 1 bigger than the bottom, then the asymptote slants. We call that a slant asymptote. So what's happening is when x is 0, you have a vertical asymptote. The graphs go into negative infinity, infinity. That's how vertical asymptotes work. As x gets bigger, it just gets closer to whatever that line is. Does that make sense to you? Right? All right? So that's kind of what I want you to be able to know by looking at these functions pretty quickly. The other thing is this, and we'll start looking at some examples like this. If you factored something out, what would happen is, since this would be the vertical asymptote, I would write this little note to myself on this. So the vertical asymptote would be x equals -5, because it's leftover ever cancellation. Whatever's left over, which would be x equals -2, is like a hole in the graph, okay? Sometimes you'll hear me call this a deleted point. I think our textbook uses the term deleted point. I think of it just as a hole in the graph, and we did talk a little bit about that last week. So anytime the one that cancels, that's no longer a vertical asymptote, okay? And you'll see that because I'll do a couple of examples like that. All right, so is there any question about asymptotes? That's step number 1 when you're dealing with rational functions. You want to know how the asymptotes work, okay? All right, and if you're going to take calculus, actually rational functions, you do a whole lot of work with these. You do stuff called limits, so it's pretty important to get a pretty good understanding of this, okay? All right, and if you take like trig, if you're going to take trig or pre-calculus, the trigonometry, a lot of the graphs have asymptotes too, so it's kind of good to get a good handle of this now. Okay, let's go ahead and start with this one. Okay, we're going to now put it all together and do the graphing. The first thing you could do is, I always say that you ought to try to factor stuff and see if anything reduces. That's definitely wrong. So that should be 2x, 2 parentheses x plus 3. So you can take a 2 out of the top like that, and nothing cancels. But it's always good on a rational function to start that way, okay? Now, let's see if you can figure out, I'm wanting you to know the answer to part A just like that, okay? What's the degree of the top and bottom on this problem? They're both 1, so they're equal, right? So the degree of the top is equal to the degree of the bottom. Okay, can you tell me in your head what the horizontal asymptote is?
2.
Y equals 2, good. Y equals 2 over 1. So again, that's what that horizontal asymptote is, okay? So we're just going to get y equals 2 like that, okay? Now what I'm going to have you do is we're going to kind of put this together as we go. So let's go ahead and go to your graph, and let's go ahead and just take a dashed line through y equals 2. Okay, this is your horizontal asymptote. So you want to label that. Just use a dashed line for asymptotes. That way I know what they are. So it goes like that. Now here's what this is going to say. Whenever the graph goes this way, you're just going to be real close to 2. The further you go this way, the closer the graph gets to 2. Now, it could be on top of that, or it could be below on that. Same way this way. If you go forever that way, the graph is just going to level off at 2. Okay, that's what that part of the problem right there already means. Okay, right? Now let's go ahead and do the next one right here. Vertical asymptote. What do you look at to find the vertical asymptote? The bottom. Okay, so what is it? X equals 1. Good. Okay, so you set the bottom equals 0, solve the equation. You can do that in your head. So that's x equals 1. Okay, so we got that. So go ahead and go to your graph and draw a vertical line through x equals 1. Okay, and label that. Okay, so whenever you're graphing rational functions, the first place to start, to me, is to go through and just kind of get your asymptotes if you have them. Sometimes you don't have any asymptotes on it. It just all depends on the situation. Now, what you want to immediately know there is the graph is either going to go to infinity or negative infinity. You don't know which way. It could both go to infinity, they could both go to negative infinity, or one of each. Okay, so I'm going to show you how to figure that out in just a minute. Okay, all right, so we got our asymptotes. Next thing we do is an X-Intercept. When you do an X-Intercept, you really set the function equal to 0. So if you go back to the function, f of x is, we're just going to let f of x be 0. Then we have 2x plus 6 over x minus 1. So we got to solve that equation. And really what you do with this is you want to get rid of that fraction. So how do you make the x minus 1 go away? Just multiply by it, right? Okay, so you have an equation that's got a fraction in it. What you want to do is just go ahead and multiply both sides by that, okay? And that's going to eliminate your fraction. This side is going to be 0, so you're going to get 0 equals 2x plus 6, and then you can solve that equation. What you really end up doing on an X-intercept on a rational function is figuring out what makes the numerator 0. So from here, you could subtract 6 from both sides. That would give negative 6 equals 2x. Divide by 2, you would have x is equal to negative 3, so we write that as negative 3, 0. Okay, so that's what you're always going to do on a rational function, is set the function equal to 0, solve the equation. Sometimes you'll get an answer, sometimes you won't. Sometimes you might get 2 answers. So let's go down to our graph, and let's go to negative 3 and put a dot there. Okay, so that's an X-intercept right there. That's 1 point on our graph. We know that. Okay. All right, how do you find a Y-intercept? It's the opposite thing. What you do is you set x equals 0. Okay, so what you do is you would take the function that we have, 2x plus 6 over x minus 1, and what you want to do is just replace all the x's with 0. So that would be 2 times 0 plus 6 over 0 minus 1. For simplify, that would be 6 over negative 1, so that's negative 6. So that means that you want to write that usually as a point. X is 0, y is negative 6. Okay, so what that does is that gives you your y-intercept. So what you would want to do is go to your graph and just put a dot on the y-intercept that just go down 1, 2, 3, 4, 5, 6. And then you've got 2 points on the graph now. All right. So what I've done so far is I've reasoned out the asymptotes and the intercepts. That's the way you should always start these problems. Okay. Now we're going to do the domain and range at the end. That's the last thing that you probably should do. So the next thing I'm going to show you how to do is how to do a sign chart, because you want to be able to do this without your calculator. You want to be able to just make a nice sketch of this graph without having to use your calculator. And you need to know how to do sign charts for a calculus class anyway. So what I want you to do down at the bottom is I want you to just draw a number line. And what you always use is you use X-intercepts. This is something you should write down. Use X-intercepts and vertical asymptotes. When you make your sign chart, if you have an X-intercept, you need to pay attention to it. And if you have a vertical asymptote, you need to pay attention to that. So if you go back on this, it looks like the vertical asymptote was 1. So we'll have x equals 1. And then we had the x-intercept was, what was that, negative 3. Okay, so we have that. Now what I like to have students do is just kind of use dashed lines there. And if you have something undefined, it's, you know, a reasonably good idea to just put U for undefined. So you have a vertical asymptote there, and then you have an x-intercept there. Okay, it's worth labeling that, but you don't have to. So what we're going to do is we're going to use this information to figure out how the graph is behaving. All right, so here's what you basically do. Let's go ahead and somewhere at the side, just like in here somewhere, just write down the function, which is 2x plus 6 over x minus 1, so I can show you what I'm doing with that. Okay, this is called a sign chart, and this will tell you how the graph behaves. Then we can do a sketch of the graph. Okay, so what you do is you use test points. Give me a number that's smaller than -3. -4. Just keep it as simple as you want to, but it doesn't matter what you use, you'll always get the same result. So what you're going to do is you're going to plug that into the function. So we're just going to do 2 times -4 plus 6 all over -4 minus 1. Now you don't have to get a numerical answer to that. All you got to do is determine if that's negative or positive. So the numerator on this is really -8 plus 6 over -5. So what I see is I have a negative numerator, a negative denominator. So a negative over a negative is equal to a positive. Okay, so I'm just going to put an answer there. And what that means is that means all of the y values are positive. So it means all of the y values are above the x-axis. Okay, that's what that means. Now, as I go through this, I'll show you what the graph has to look like. So what I just showed you is when you're to the left of -3, the y value are all going to be above the x-axis. So what's going to happen is it's going to go like this. And what's it going to do with that asymptote? It's just going to get close to it, right? So what you're going to do is just sketch this in kind of like that. Okay, that's what that part of the sign chart tells you. So what you want to do next here is just kind of sketch that in. Okay, it's not going to touch the horizontal asymptote, it just gets closer to it. And it doesn't have to be perfectly accurate, you just want to get the idea. Okay, so the next thing we do is we do a test point between -3 and 1. What do you want me to use here? Let's go with 0 because that's easy. Okay, so plug in to your function again. So that's 2 times 0 plus 6 over 0 minus 1. Again, the numerator is positive. That's what you care about. The denominator is negative. So positive divided by negative is negative. So that means all of your y values are negative, which means you're below the x-axis. Okay, again, you just need to figure out if that test point makes the function negative or positive. Okay, does that make sense what I'm doing? Okay, now here's what's going to happen on this. Now just think about this. This region from -3 to 0 is going to be below the x-axis. So it's going to have to connect, and then it's going to go to -infinity because that's the way vertical asymptotes go. All right, so see what we're doing is the sign chart's just sketching the behavior. So what you're going to do is just kind of connect the dots and then get close to the vertical asymptote but don't touch it. So what this is saying is you're above the x-axis there and then you're below there. Okay, does that make sense what I'm doing? Okay, so I just care about whether I'm above or below the x-axis, and that's always enough to reason out how the graph goes. Okay, what test point do you want me to use here? 2. You read my mind. Let's just keep it simple. So we're going to do 2 times 2 plus 6 over 2 minus 1. Okay, just look at that. Is that positive or negative? The whole thing. It's positive. The numerator is positive. Denominator is positive. Positive divided by positive is positive. So therefore that means that you're above the x-axis. Okay, that's what that means. Now, when you go through and start putting this graph together, you know that whenever you're bigger than 1, you have to be up here. So what's going to happen? You're going to have to go to infinity, right? And then you're going to have to level off. So you'll actually be above this asymptote and to the right of that asymptote. It's the only thing that makes any sense. So all I'm trying to get you to do is a rough sketch. So you know that would go to infinity, and you know that would level off. So just kind of sketch it in. Okay, like that. Okay, that's good enough. That's a real accurate sketch of that graph. It's not perfect, but that's what you would find if you put this in the graphing calculator. Okay, so what I need to kind of see is if you guys are following how I do this sign chart, because when you do this on your exam 3, you'll do this without a calculator. And your job would be to figure out how this graph behaves by doing that sign chart. Okay, does that make sense? You guys know what I'm doing okay? All right, so be sure that you know that if you have a vertical asymptote, the graph either goes there or it goes there. Horizontal asymptotes, it levels off. You have to know that then put that information together, okay? All right, let's look at the domain and the range on this, okay? Where is this function undefined? There's one place. Where is it undefined? At 1. So what we could say here is we can say set of x, and we just say x is not equal to 1. Okay, you can write it that way for your domain, or you could write interval notation. You can say negative infinity to 1, union 1 to infinity like that, okay? Now, you always want to kind of do this range after you've done the graph. Look at my graph. Is there any value that y is never equal to? There's one thing. You know what it is? 2. Yeah, it's not 2. It's never going to get to 2. It's just going to get close to 2. So what we would say on the range on this is we'd say this. You can write it as set of y. Y is not equal to 2. So you look at the horizontal asymptote on that. So that one, y is anything but 2. And if you wrote that in interval notation, you would say negative infinity to 2, union, and then 2 to infinity like that. Okay, so that's how you would write your domain and range. Okay, all right, so this is kind of what you're going to be doing on these problems is finding asymptotes, finding intercepts, doing a sign chart. The sign chart helps you to make a sketch, and then domain and range. Is there any problem anybody's got or any questions so far? Okay. Okay, they're all going to be a little different, but they're going to have a lot of the same basic ideas to it. Okay, so let's go to this next page here. Okay, so let's start with the horizontal asymptote. And this is something you do in your head, all right? So the degree of the numerator is what? 1. What's the degree of the denominator? 2. What does that tell you? That's a rule, okay? If the degree of the top is less than the degree of the bottom, you remember which one that is, or have you already forgotten? Y equals 0, good. Okay, that's rule number 2, okay? So we got that. So that is your horizontal asymptote, all right? So what we're going to do is go to your graph, and if you have a horizontal asymptote y equals 0, hey, that's the x-axis. So just put a dashed line kind of right alongside the x-axis. Like that. So that takes care of that. That's a good place to start is get your asymptotes put together. Okay? All right, now let's go ahead and let's take a look at the vertical asymptote. What do you need to do to find a vertical asymptote? Set the denominator equal to 0. Exactly. Find out where it's undefined. Nothing reduces on this or anything. So you would solve the equation x squared minus 4 equals 0. What's the answer to that equation? Plus minus 2, right. Okay, so you'd have x squared equals 4. Then you can square root both sides. So you'd have x is equal to plus or minus 2. So you can write your asymptotes as plus minus 2. Just understand that there's 2 of them. That's an abbreviated way to write that. Okay, so now what we're going to do, I'll have you go down to your graph and just put a vertical asymptote through x equals negative 2. Okay, and we'll do that. I'm going to write that as x equals negative 2. And then we're going to put the other one at x equals positive 2 like that. So once you get your asymptotes out of the way, that kind of gives you a framework for how your graph is going to behave. All right? So see, one of the things you know already is when you're out here, the graph's going to level off at 0, right? Now it could be above, it could be below. That's what the sign chart does. When you're way out here, the graph's going to level off, but it could be above or below. But you're going to know that. And again, that's what the sign chart is going to help you determine. Okay? All right, let's go to the next thing, X-Intercept. So on an X-Intercept, what do? Set the function to 0, or set y equals 0. So you would have 0 equals x over x squared minus 4. Okay? Now you can kind of bypass what I'm doing here. If you do this, all you're going to do is multiply both sides by the denominator because you have an equation with fractions. So what you'll have is the left side is going to be 0. The right side's going to be x, okay, after that cancels out. So that means when x is 0, y is 0. So remember, we set y equals 0, and we found x to be 0. So that's your intercept. So what you do is go to your graph, go to 0, 0, and put a dot there. So you have 1 point on your graph now. We have 0, 0. Okay, so that's what you always do is set the function to 0. Okay, what do you do on a y-intercept? Set x equals 0. Okay, it's always easier to find an x-intercept. So we just do f of 0 So that's 0 over 0 squared minus 4. That's 0 over negative 4, so that's 0. It's the same thing, okay? It's the same point. So the point 0, 0 is an x and y-intercept at the same time. Okay, so we got that. All right, so far we've got our asymptotes, got our intercepts. Now we're going to move to this sign chart, all right? Now one of the things that you want to do is you want to draw a number line. And remember what I said you use. You use two things. You use vertical asymptotes and you use X-Intercepts. That's how you break this thing up. So if you look at this, we had x equals 0 was an X-Intercept. So it's a good idea to just write a note to yourself that that's the X-Intercept we found. What were the vertical asymptotes? 2 and negative 2, is that right? Yeah, okay, so we've got, just do this. You can put undefined or you can put vertical asymptote there if you want to. And then do another one here. So we have 2 vertical asymptotes. They are at x equals negative 2 and x equals positive 2. Okay, and always use X-intercepts and vertical asymptotes. Don't use anything else. Okay, now what I'm going to do is I'm going to write down the function that we're working with, just kind of, so as I'm showing you this is what we're going to be analyzing, is x over x squared minus 4. So what you're going to do is your sign chart, you're going to plug into your function, figure out if it's above or below the x-axis. Okay, we're going to do the same kind of thing here. So let's use test points. Out here, let's use like negative 3. So you want to go ahead and plug negative 3 in to your function. So that would be negative 3 over negative 3 squared minus 4. Okay, now you don't have to work that out. The numerator is negative. What's the denominator in your head, positive or negative? Because it's 9 minus 4, right? So that's positive. Okay, that's all you got to do. And then negative divided by negative is negative. Is that below or above the x-axis? That's below. Okay, so that means that you have figured out that we're below the x-axis. Okay, so if you go to your graph now, that means whenever you're to the left of negative 2, you're going to be below here. All right, what's it going to do? It's going to go to negative infinity, right? Because that's what happens around an asymptote. What's going to happen here? It's going to level up. So you're going to have kind of a shape that looks like that. Now, it doesn't have to be perfectly accurate. At a minimum, what I want to see is that you're kind of showing that levels off and that goes to infinity. And then you just kind of connect them somehow like that. So it'll have a rough shape. All we're doing is looking kind of at the rough shape. That's not real accurate. It'll be a little better if I drew it this way. So just kind of make it get close to the asymptote. Whoops, what am I doing? I'm on the wrong side. What did I just do? I'm over here. So what I need to do is do this and do that, then connect the dots kind of like that. That's what I want you to do, okay? Just get that rough shape, okay? Now we're going to go in between negative 2 and 0, so let's use like negative 1 as a test point. Again, plug into your function. So the numerator is negative 1. The denominator is negative 1 squared minus 4. Okay, so the numerator is clearly negative. What's the denominator? 1 minus 4? That's negative. Negative over negative is positive. What does that tell you? You're above the x-axis. Okay, that's what that does. Okay, so now if you look at this part of the graph right here, just between 0 and negative 2, you would have to be above. So what's going to happen? It's going to go to infinity because that's what happens at a vertical asymptote. So just sketch a shape kind of like that, right? So this one would go connect the x-intercept, just kind of make it go to infinity like that. That's what that tells you, okay? Right, then we go to the next thing. The next region is between 0 and 2. We'll use 1 as our test point. So if you plug that into your function, that would be 1 over 1 squared minus 4. Numerator's positive, denominator's negative. Positive divided by negative is negative. So that means you're below the x-axis, okay? So what's the graph going to do here now between 0 and 2? What's it going to have to do? Yeah, it's going to have to go down and get close to that asymptote. So that's what I want you to know how to do, is that this is giving you enough information to draw a good sketch. So that's how that goes, okay? All right, and then the last part we're going to do is look at what happens when x is bigger than 2. So let's use a 3. Again, plug into your function, so you'll have 3 over 3 squared minus 4. Numerator's positive. Denominator's 9 minus 4, so that's positive. So positive over positive is positive. That means you're above the x-axis like this. So think about what's going to happen out here. You're going to be up here. What's it going to look like out here? Yeah, exactly. Okay, it's going to go like that, approaching the asymptote, and leveling off at the horizontal. Okay? So all you got to do is just kind of draw a rough sketch of that. Just kind of go down and kind of that type of shape like that. And the only way you're going to get the graph more accurate is just to make a table of values and get some accurate points. But that's what I'm after, is a rough sketch of the function like that. Okay, the domain. If you look at look at this function, this is our function, x over x squared minus 4. What did we find out? Where is it undefined at? 2 and negative 2, right? Okay, so what you can do is you can write this domain as the set of x, and x is not equal to plus or minus 2. Okay, that's how you write that in set builder notation. If you write it in interval notation, you have to say negative infinity to negative 2, that's all acceptable, and then negative 2 to 2, and then 2 to infinity. And what you're doing on that is, since you're using parentheses, you're telling me that it can't be 2 and negative 2. So you want to be able to write that both ways, okay? All right, now look at the range real carefully. Is there any value that y never hit? Look at my graph. It did hit 0, okay, because that was an x-intercept, right? Now, one thing about this a lot of times confuses students. You can touch the x-axis, you just can't touch it out here, okay? So when you have a horizontal asymptote, that really is talking about what is the graph doing when x gets bigger. It's okay to touch it there. You just can't touch it way out there. Does that make sense? Okay, so basically on this, it would be all real numbers. So your range, if you just look at this part of the graph right here, that took up everything. Okay, so what we'd say on this is we can just say all real numbers is okay if you say that, or interval notation, you just say negative infinity to infinity, like that, okay? And that's the idea. Okay, get your calculator out, so go ahead.
What's all the way out? Is it
okay, like is, if x is getting bigger and bigger, as x goes to infinity, when x gets bigger, y is never going to hit 0.
Okay.
So I'm talking all the way out, I'm just talking about what's the graph doing at infinity and what's it doing at negative infinity.
Okay.
So it can't touch the x-axis there and there, but it's okay to touch there. It just can't touch at infinity, okay? All right, let's put this in the graphing calculator. One thing I want to show you on this is when you're doing these things on graphing calculator, you got to, if your denominator has more than one term, use parentheses. So the way you'd have to put this in is x divided by, and then parenthesis, x the second minus 4, and then close parentheses. So you don't need parentheses around x because it's just one term. A general rule of thumb is to put both the numerator and denominator in parentheses, and you'll never go wrong. Okay, so that to me is a real important thing to make sure you know. Now I'm going to go zoom 6, and we'll just see if this follows the graph we came up with. It looks pretty much the same as what we did. It's got the same basic structure as what we had. All right, so you can always tell you're correct on a graph by doing that, but if you're doing your homework, don't use your calculator. Use your calculator to check, because if you just plug in your calculator and that's all you do, you won't learn what I'm trying to get you to learn, okay? Do the sign chart and all that stuff, okay? Then you'll get this down a little better. Okay, let's go to the next one. This has another different thing in it. Every problem has a little twist to it, so this one has a twist to it. Okay, so again, we're going to kind of follow this same strategy. This one's a little bit different in a couple of regards. First of all, let's go ahead and factor. It looks like the numerator factors and it looks like the denominator factors. So you can take a 3 out of the top. So that would give you 3 parentheses x plus 1 like that. The denominator is a trinomial. So let's go ahead and let's do that. So that would be x and x. Then you'd have 2 times 1. And you'd have a minus and a plus. Okay, so we got that. Now here's where you got to be super careful about this problem. So what happens is you have x equals 2, and then you have x equals negative 1. Now, this one cancels out. So since it canceled, okay, that's going to give what we call a deleted point, okay, or just a hole, A lot of times I just use those words interchangeably. So if you go down to part E, the deleted point is just x equals -1. Now you don't know what the y value is. That doesn't matter. It's just when x is -1, you're going to have a hole in the graph. You're not going to have an asymptote. Okay? This one is an asymptote. So this one right here is a vertical asymptote. So we've already got our vertical asymptote. That is x equals 2. Okay, so that's how you want to start that problem. If you can see that you can simplify that, then you want to do that. Okay? And then that just gives us that f of x, after the cancellation, you get 3 over x minus 2. Does that make sense to everybody? So the one that canceled, deleted point. The other one that's left over is a vertical asymptote. So you're not going to have 2 vertical asymptotes because one of them canceled. Okay? All right, now let's go to the horizontal asymptote. So the degree of the top is what? 1. Degree of bottom is what? 2. So since 1 is less than 2, what's the answer? Y equals 0. Good. Okay, remember that's a rule. Anytime the degree of top is less than the degree of bottom, then you got your answer automatically. Okay? All right, so let's go ahead and put our asymptotes on here. So let's go ahead and go down to the graph, and let's go ahead and get these two things kind of put together here. So let's see. I'm going to go to x equals 2, go to x equals 2, and then put your vertical asymptote like that. Okay, that's an important part of the graph, so that's a good starting point. All right, then we have the horizontal asymptote was y equals 0 again, so like the last problem, just kind of dash the x-axis so that you know that that's there. So that's your horizontal asymptote like that. Okay, all right. Next thing to do is to find the intercepts. Now the intercepts, what you want to do on this now is this, and this is real important. You want to use the reduced form. Okay, because if you don't do this, you'll end up with something you'll come up with a x-intercept that's not there. So after we reduced, we ended up with 3 over x minus 2. So what you want to do is, like we've been doing, you set f of x equals 0, but you want to set that equal to the reduced form. So we're going to do 3 over x minus 2 like that. So that's the equation you're going to solve on that then. Okay? So what happens on this, if you have 0 is equal to 3 over x minus 2. You have an equation with fractions. So what you can do is you can multiply both sides by x minus 2, so that goes away. And something weird's going to happen when we do this. Okay, the left side's going to be 0. What's the right side going to be? That's kind of weird. What do you think that tells you? Remember, we're trying to find an x-intercept right now. That's nonsense. So what do you think? We don't have one. Okay, that means we don't have one. Okay, all right? So you got to go like that. So you're going to find on this problem that you're not going to have an x-intercept. Okay, and that's because this equation, when you set the function equal to 0, you don't get an answer. This has no solution. Okay, right? Now we go to the y-intercept. So if we do the y-intercept, you let x equals 0, and it doesn't matter which form you go to. You can go to the reduced form or to the non-reduced form. You'll get the same answer. So let's just take f of x equals 3 over x minus 2 and then plug in 0. So if you did f of 0, you would have 3 over 0 minus 2. So that's 3 over negative 2, which is negative 3/2. Okay, so your y-intercept is going to be, when x is 0, y is negative 3/2. Okay, so that's your y-intercept like that. Okay, so let's go to our graph. That's like negative 1.5. So just go down negative 1.5 and put a dot there. Okay, so we got an intercept. All right, and that's all we got is we got 2 asymptotes. We have a y-intercept. Now we're ready to do the sign chart and put this thing together. Okay, does everybody understand the deleted point and vertical asymptote part? Okay, that's what you got to be aware of. Okay, all right, now we're going to make our sign chart. So when you do that, you want to draw a number line. And remember what I said on this is when you do your sign chart, you always want to use vertical asymptote and x-intercepts. That's what you use. Okay, so if you look at the results, we did not have any x-intercepts. There were no x-intercepts, and we did have 1 vertical asymptote. So our sign chart, we're going to look at x equals 2, is where we have a vertical asymptote, and that's it. Okay, we don't have any X-intercepts, so it doesn't matter. So let's go ahead and put X equals 2, and then let's do a vertical asymptote. Now what you can do on this, again, is you can use the reduced form. Okay, it doesn't matter on this sign chart if you use the original function or the reduced form. The reduced form is less work, so let's write down 3 over x minus 2, and then let's do some test points in there, because it'll work either way, all right? So you might as well just use the reduced form. Okay, so let's take a test point below 2. Let's take whatever. Let's take 0, okay? So we would have 3 over 0 minus 2. You have a positive numerator, a negative denominator. Positive divided by negative is negative. So like we've been talking about, that means that you're going to be below the x-axis, okay? So if you look at this, you can figure out how the graph's going to go. So when you're below 2, the graph's all below the x-axis. What would that have to look like, roughly? What's happening here? Leveling off, then what's it going to do? Yeah, like that, right? Okay. So it's all below the x-axis, and it's got to go through that y-intercept also. Okay, so it's going to look kind of like this. So you just kind of sketch through that, make it get close, and then make it go down to infinity around the asymptote. That's it. Okay, that's what the sign chart's doing for you. Okay, now we go to a number bigger than 2. Let's do like 3, for example. Plug that into the function, which is 3 over x minus 2. You would have 3 over 3 minus 2. That's a positive numerator, positive denominator. So that's positive. That means you're above the x-axis. Okay, and that's all you got to know. So what's going to happen is when you're to the right of 2, you're going to be up here. What's it going to look like, roughly? Trace it out. Exactly, like that. It's going to go like that, and then go to that asymptote. So it's going to go to infinity, and then level off like that. All you got to do is just kind of sketch it. Doesn't have to be perfect, but just the idea. So make it go towards the asymptotes this way, and then just kind of connect the dots. Okay, if you got the shape down, that's good enough for me at this stage of what we're doing. Okay, now if you look at your domain, now this is where you got to be kind of careful. You don't use the reduced form, you want to use the original. So on this domain, you want to be sure you do the original, which was 3x plus 3 over x squared minus x minus 2. Then I'll show you how to locate this hole in this graph here in just a minute. We hadn't done that yet, so we'll do that. Okay, so what you do on the domain is, remember when we factored this, we had 3 over x plus 1, and then I think we had like x minus 2, x plus 1. So look at this point. What are the 2 places where this is undefined in your head, now that I got it factored? 2 and negative 1, okay? That one still counts, even though it crossed out. The original function's undefined at 2 places. So when you're doing your domain, you have to say set of x, and you have to say x is not equal to 2 and negative 1. You have to have both of those in there, okay? Because again, what you want to do is you want to use the original function like that, okay? All right, now look at the graph we came up with. If you look at this graph, is there anything that y is never equal to? There's one thing. What is that? 0. Good. Okay, this thing didn't have any x-intercepts. It's never going to touch the x-axis because of the horizontal asymptote. So what you would say on the range is you'd just say set of y, and you'd say y is not equal to 0. Okay? Now, that'll leave us with the last thing, is this deleted point. So we had this deleted point of negative 1. So what you do on this is this. You just go to negative 1 and you put a bubble there. Okay? Just put a little dot there. That's all I want you to do is locate that. So that right there is called the deleted point. Okay, that's going to be a little hole in the graph right there. It's not an asymptote, it's a hole in the graph like that. Okay, all right, now let me show you. I want you to do this on your calculator because you want to be able to kind of make sense out of this stuff as you're learning this. So put the original thing in your calculator. Okay, don't put the reduced form, do the original. So we have 3x plus 3, that's the numerator, make sure that's enclosed in parentheses, and then the denominator is going to be x to the second, and then minus x minus 2. Close parentheses and do that in the standard window. Okay, so we're just going to do this. and we'll see if this looks like what we just did. Now the bubble's not going to come out. Maybe it does on advanced calculators, but it doesn't come out on this one. So one thing you can tell is you have a vertical asymptote at x equals 2. There is a bubble there, and let me just show you how you know that. So if you traced at -1, so if you get this in your calculator, just type trace -1, and what's going to happen is y is nothing, okay? Right there it has a blank in it. There would be undefined there. So right there is where you have a little hole in the graph. And the reason it's a hole is because on both sides of it, it's getting close to the same value. Okay, so all I really want you to do on that is just sketch your graph like that and just put a little open bubble on that. So this thing is undefined there, and it's undefined there. There's two places it's undefined. Okay, tell me if that makes sense or not. Okay, now let me show you this also. Okay, now I want you to do this too. Go to Y2, and in Y2 put in the reduced form, 3 over x minus 2. And what I want you to see is if it's basically the same graph. It's not exactly the same graph, but it's basically the same graph. So if I put that in, okay, it's just going to trace over that. The only difference is the reduced form is only defined at 2, so it doesn't have the bubble in it. So they should be exactly the same thing. So that graph is the same as the graph we're looking for, except it's missing the deleted point. Okay, so that's one of the ones that's a little harder to do, but you want to be able to handle this situation when it's got a deleted point in there. This stuff will show up in calculus. All right, is there any questions about what I did on that? Okay, all right, let's do one last one. I think I'm going to do like a couple more, but one main one, this example 4. Example 5, I think I just put that together to do on the calculator to just give you an idea of how something goes. All right, so let's go ahead and take a look at this one. This is the other main type of problem that you want to do on here then. Okay. All right, so with this one, let's start with the horizontal asymptote. Okay, what's the degree of the top? 4. What's the degree of the bottom? 3. Okay, so that's the highest exponent. So anytime the degree of the top is greater than the degree of the bottom, what's the deal with the horizontal asymptote? You don't have one. Good. Okay, so that's the conclusion that you draw because of that. Okay, now what it's going to have is it's going to have what we call a slant or an oblique asymptote. So we're going to find that, and we'll find that in just a minute here. Okay, this is kind of a weird problem. I probably could have come up with a better example than this also. But we're going to mostly do this problem on the calculator. So the first thing I want to do is let's go to the side here, just kind of at the paper. We're going to find the slant asymptote. So we're going to do long division. So we're going to divide by x cubed minus x squared plus 1. Okay. Now what I'm going to do here is we're going to put under the division symbol, we're going to put the numerator, but we have some missing terms, so let's put 3x to the 4th plus 0x to the 3rd, because there's a missing term, minus x to the 2nd. We have a missing 0x, and then we have a missing constant term. Now we cannot do this problem by synthetic division, because the only time you can do synthetic division is when you divide by like x plus something or x minus something. So you got to deal with long division. If you're going to do calculus one day, you got to be able to do both synthetic and this, both. Watch this carefully, because this is kind of a little different than long division, but this is how you find the slant asymptote, and that's something that I want you to know how to do. Okay, step 1, you're going to divide these two things. Okay, I'll just kind of write the steps here, write down the steps if you need to. So we're going to do 3x to the 4th divided by x to the 3rd. What is that, by the way? What? 3x, good. Okay, one of the x's cancels out. So let's see, that result, doesn't matter where you put it. You can put it above, it doesn't make any difference. So just put a 3x up there somewhere. Okay, all right, and then what we're going to do is step 2, like we've done before, is we're going to do 3x, and we're going to multiply it by the divisor. And then we're just going to record that under the like terms. Okay, this is the same thing that we've done before. So that's going to be positive 3x to the 4th, minus 3x to the 3rd, and then plus x, or plus 3x, sorry. Okay, then we're going to line that up under the like term. So you're doing the multiplication step like that. Okay, so now what I'm going to do is just record that under my like term. So I have plus 3x to the fourth, minus 3x to the third, and then I got a plus 3x there. Just make sure everything's lined up and accounted for like that. Okay, all right. So now the next thing we do is we subtract. Okay, this is the most common place where students mess up too, so watch carefully. Okay, so what you're doing is you're doing this. Okay, you're doing 3 minus 3 is nothing. That cancels. Okay, how about this one though? This is 0 subtract negative 3. So what's that? 0 subtract negative 3, what's that? What's minus minus? Plus. Okay, so that is positive 3x like there. Okay, if it helps you, just kind of change this to plus, because when you subtract, you change signs anyway. So 0 plus 3 is going to be 3x to the third. Okay, so that's like that. This thing just comes down. Okay, so that's minus x squared. And then this thing right here is the same thing. Remember, you're subtracting. So you're doing 0 minus 3x is going to be negative 3x. Okay, that's good enough. And then if you bring down the next number, you get a 0. So this is the same procedure we've done. I don't think we've done one that looks quite like this before. So that's how that goes. And then step 4, like we say, is we just bring down the 0. Then we start over again. So what I'm going to do now, when I go back to step 1, what am I going to divide, by the way? 3x to the third and x to the third. That's all you look at when you do that division step is that. So we're going to do this. We're going to do 3x to the third divided by x to the third. So what is that? That's 3. That's a positive 3. So you want to put the positive 3 result like there. Okay? And actually you can stop there because this thing right here is the oblique asymptote. Okay, an oblique asymptote's a line. Doesn't that look like a line? Y equals mx plus b. So this thing right here is the oblique asymptote. You don't have to move on. Once you get that line, then you're done. So let's write in here that the oblique asymptote, okay, that's going to be y is equal to 3x plus 3 like this. Okay, so that's what we get. Now this is a really good calculator problem because of what happens on the rest of the problem. Okay, so I want you to know how to do that. Now the next thing we got to do is if you were to go through and factor the numerator you can take an x squared out of. So if we go back to the beginning of the problem, you can take an x squared out of the top. You'd have x squared times 3x squared minus 1 all over x to the third minus x squared plus 1. Okay, so we've got an oblique asymptote, and we're going to go ahead and graph that. And this is something you learned how to do a long time ago. So if you graph y equals 3x plus 3, this is the y-intercept. Okay, 3 over 1 is the slope. So you want to just graph that out. Okay, so we'll do this then. Go up 3, and then just count out your slope. Your slope's 3 over 1, so you go up 3 over 1, up 3 over 1 just a couple of times, and then do a dashed line like there. It doesn't have to be perfect, but if you can get 2 good points, then that would be a good oblique asymptote. So that's y equals 3x plus 3. And what's going to happen now when you have an oblique asymptote, when the graph goes all the way out to infinity, the graph is going to get close to the line. And when you go this way, it's going to get close to the line. Now it could be above or it could be below, but the graph is going to go that way and that way, like that. That's what we're going to see when we go to the graph and calculator. Okay, the next thing we have to do the calculator on. So this is not, I probably could have come up with something a little simpler, but what you want to do to find the vertical asymptote is you want to set the denominator equal to 0. Okay, and this would be a technology problem because that's not a quadratic equation. It doesn't factor. You have to do that on your calculator. Okay, so get your calculator out so I can take you through how you would have to do this then. Okay. All right, now we're not graphing. We're not ready to graph our equation yet. So what I'm going to have you do is put in this part right here. So just go to y equals and put in, erase everything that you have first of all, if you got some other stuff in here. We're going to put in x to the third, and then minus x squared, Oops, I always do that. Always do that. So it's x to the third, and then minus x squared, and plus 1. And just do that in a standard window. So once you get that put in, just go zoom 6 for a standard window. Okay, now what we're going to do is we have to use our technology to figure this out. Okay, the answer is right around -1. Now we're going to figure out precisely what that is. So what we're going to do is we're going to find the 0 on this. So what you do is you go second trace to open up the calc menu, and then you use option 2, which is a 0. So when you get that, you want to press enter, and then you're going to get a left and right bound. So you want to use your left cursor key, get a little bit to the left of where that X-intercept is. Once you get that, press enter. Now it's going to ask for a right bound. So move the cursor key somewhere to the right of the X-intercept. Somewhere like that's good enough. Press enter. When it says guess, press enter. And then it should come up with 0. So that 0 is at, this is the X-intercept, that's about -0.75, and that's an approximation. So there's times on these problems when you have to use your calculator, okay, because if things don't factor, then you're not going to be able to find that correctly and everything, okay. So that basically is your X-intercept right there, okay. Now the vertical asymptote on this, what you're going to find on this one, whoops, hold on, that's the wrong thing. We were finding the asymptote. So what we want to have is you want to have this. You want to put that x is -0.75. That's your vertical asymptote. That's the X-intercept of what makes the denominator 0. So that's what you would do there, okay? All right, now the next thing we're going to do is we're going to find our intercepts, and then the rest of this problem, we're going to have to use a calculator because it's pretty complicated. I'm not even going to do a sign chart on this one. So what we want to do on the X-intercept is you want to take the function, let's take like the factored form, and let's set that equal to 0. Okay, so I think we're going to end up having like 3 intercepts on this. So you want to do that. That's always what you do to find an X-intercept. So what you do, and you get to a point where you don't have to do this anymore. If you're going to solve this equation, what are you going to do to both sides? You're going to multiply by what you're trying to get rid of, okay? So, I mean, like I said, you can do this in your head, because what's going to happen is that's going to cancel out, and then the right side is still going to be equal to 0. So you would end up with the equation 3x squared times 3x squared minus 1 equals 0. Now you got to solve that equation. So it's in the factored form, so you would have x squared equals 0. Then you would have 3x squared minus 1 equals 0 like that. So if you can solve those two equations, you'll get all your intercepts, and there is 3. This one you do square to both sides, so you get x equals 0. So that's one of your intercepts right there, okay? Then this one you use square root property on, so you got to move the 1 to the other side, divide by 3, so you would have x squared is equal to 1/3. Then you do square to both sides, so we have x is equal to plus or minus, and the square root of 1 is 1, then you leave the square root of 3 like that. So what you would have for your intercepts is you would have those 3 intercepts right there. So let's just write these as points. So we would have 0, 0. We would have -1 over root 3, 0. And then we would have 1 over root 3, 0 like that. So these right here are your 3 X-intercepts. Okay? Now see, it's a little bit more complicated because now that one right there is just, it's already factored, so we solved the equation x squared times 3x squared minus 1 equals 0. It's already factored. So that gives you what your intercepts are, okay? All right, now the Y-intercept, what do you do on a Y-intercept? It's always the same. You set x equals 0. So go to your function. You can probably do this in your head. If you let everything be 0, all the x's equal to 0, what's the numerator going to be? Because that's all that matters, by the way. Is that going to be 0? Okay. Yeah. Okay. So we've already got that. So if you go ahead and work out the details on that, you're going to get 0. So your X-intercept is also 0, 0 like that. Okay. Now the rest of this problem, this is because it's fairly complicated. We're not going to even bother doing a sign chart on this. What we're going to do is we're going to do just use our calculator to kind of show you how this goes. Okay. Then we'll just do a rough sketch. The only thing I have you do sign charts on, I don't have you do sign charts on oblique asymptotes at all. So what will happen on this, there's one other thing I want you to put on your graph, and we had a vertical asymptote at x equals negative 0.75. So what we're going to do is just kind of squeeze in. You have a vertical asymptote right there of x equals negative 0.75. That's it. Then you have some intercepts, but I'm not even going to put the intercepts on here. So next thing we're going to do is just put this in our calculator. So get your calculator out, and I'll show you what to put in. I just want to give you an example of an oblique asymptote problem. So this one is going to go like this. Okay, you're going to end up having the numerator on the problem was 3x to the fourth, and then it was what, minus x squared, is that right? Okay, so that's your numerator of the problem that I gave you. So we do that, and then we want to divide by the denominator. The denominator on this was x to the third, and then it was what, minus x squared, and then plus 1. I like that. So that's the graph that we're going to do. So I want to show you that. Now, the other thing I want you to do is I want you to put in Y2, put in the oblique asymptote, 3x plus 4. And then we're just going to do like a super basic sketch on this. This is not the best example. So get that put in, because mainly I'm wanting you to see how the oblique asymptote behaves. All right, so here's what's going to happen. The one in blue is the graph of what we're interested in. Now what should come out is this. So does that look like this thing approaches the red line? Yeah, as you go further out this way, those things get real close to each other. You go this way, does it look like they connect? Okay, like that. So that's the idea. So what I want you to do is we're just going to do a real rough graph on this. I mean, it doesn't have to be perfect. So in this region here, just kind of put a shape kind of like that. Okay, like that. And then above right here, you have a couple of intercepts, and this is real hard to see. But what's happening is it's going to end up kind of approaching this asymptote. Then it's going to kind of go through something like that. It's real hard to tell, but that's good enough. Okay, because mainly what I want you to see on this is what the graph looks like when you do that. All right, so you can tell that everything approaches the oblique asymptote as x gets bigger and as x gets smaller. I want you to visually see that. Does that make sense to you? Okay. Okay. So one of the things I want you to be able to do is to do the oblique asymptote, and you do that when the degree of the top is 1 bigger than the degree of the bottom. Okay, that's a pretty challenging problem to do. Okay. All right, any questions about anything I did there? Okay, that's not the best example. It would have been a little easier if I would have given you something where the denominator factored, but you're not going to be tested over oblique. The only thing I have you do on tests is find an oblique asymptote. So I expect you to know how to find an oblique asymptote, but I'm not concerned about the graphing. Okay, this next one, I'm just going to do this on the calculator. So we're not going to really go through and do too much on this. Okay, so first of all, can you tell me what the horizontal asymptote is just by looking? Horizontal asymptote, just by looking. What's the degree of the top? 5. What's the degree of the bottom? 2. Okay, 3. Okay, so what's the answer? We don't have one. Okay, so it's like the last problem, so you don't have one. Okay, I'm not going to worry too much about the vertical asymptote. This function's undefined at x equals 1. So if you set x cubed minus 1 equals 0 and solve that equation, you'd have x cubed equals 1. Then you would do a third root of both sides, so you get x equals 1. So it doesn't have a horizontal asymptote, but there is one place where it's undefined, and it's only one place it's undefined. Okay? Now, the other thing I want to do is I'm not going to worry about the X-Intercept because you have to do that on a calculator, so I'm not going to go there. But the Y-Intercept, you would just do f of 0. So you would do 2 times 0 to the 5th minus 0 to the 3rd plus 2, and then all over 0 to the 3rd minus 1. So that gives 2 over negative 1. So that gives negative 2. So you have a Y-intercept of negative 2. Now we're going to crunch out the oblique asymptote on this one also. Okay, and then the graph, we're going to go totally to our calculator. Okay, all right. So what we want to do from here is we want to do a long division problem. So let's go ahead and do this like this. under the division bar, put 2x to the fifth. We don't have a fourth power, so put 0x to the fourth. Then we have minus x to the third. We don't have a x squared, so put a 0. We don't have an x, put a 0, and then a plus 2. You can bypass that, but I think students usually do best if they do that. Now that I'm just going to do x cubed minus 1, okay? So let's go through this and look at that, and then we'll finish up by looking at the graph. Okay, so what's the first thing you do when you do this long division problem? What do you look at? Okay, this and this, you divide that, okay? I'm going to write the steps, write them if you need to. So we're doing 2x to the fifth divided by x to the third. That's 2x squared, okay? Because the x, three of the x's cancel out. So up here somewhere, it doesn't matter where, put 2x squared, okay? Step 2, we're going to multiply. So we're going to do 2x to the second, and we're going to multiply that by x to the third minus 1. So that's 2x to the fifth minus 2x to the second. So you want to put that under the like term. So right here you would have plus 2x to the fifth, and then by the x squared you would have minus 2x to the second like that. Okay? All right, so we do that. Now the third thing you do is you want to subtract. Okay, so when you subtract, you can do this in your head. This is going to cancel right there because 2 minus 2 is nothing. This is 0 minus negative, so you got to change that to a plus. So 0 plus 2 is going to be 2x squared. So remember what you're doing is 0 subtract negative 2, which is 0 plus 2. So we do that. The next number, the only other number left that has any significance to it is the plus 2. Okay, so we need to go on, and we're actually done, and I'll explain why, is because of this. If you went through now, and if you did long division, then you're going to get something that's a fraction, so you don't have to go any further. So if you go 2x squared divided by x to the third, that's 2x times x over x times x times x. That actually gives you 2 over x. We don't care about that, okay? We're just looking at whole numbers and stuff. So this right here, this thing right here is going to be your oblique asymptote. So it's y equals 2x squared, okay? And the thing is, see, basically the remainder, you know you're done because that exponent is less than that. Anytime that exponent's less than that, you don't go any further. You don't have to. Okay, so let's put this in the calculator, and mainly I'm not going to even have you draw a graph on this. I just want to show you mostly how this works on the calculator. I don't test over this. I don't think you'll see anything on your homework on this, but I do like to just run through this one time in class because it's a little different. Okay, so put in your function. The original function is 2x to the fifth. So go ahead and get that put in, 2x to the fifth. And then minus x to the third. And plus 2. Be sure that you have that in a set of parentheses. And then divide by and make sure the denominator is in a set of parentheses so it will do the arithmetic correctly. So that's what we're graphing. And then the other thing I want you to put in is I want you to put in 2x squared. Okay, what does the graph of 2x squared look like, by the way? It's a parabola, right? So actually you're going to have a parabola that acts as an asymptote. So let's just do this in zoom 6. So once you get those two things put in, just go zoom 6. And we may have to play around with this a little bit, but I want to see if you can see what I want you to see on this. I think we may have to zoom out on it one time. That's not bad, okay? So if you go through and do this, let me move this over here. I'll show you. This is kind of what I'm wanting you guys to see on here. Okay, so I can actually zoom on this little thing right here, and you can see it a little bit better. Okay, so notice what's happening. As x gets bigger, what's the graph doing? It's getting close to the parabola, right? Okay, and then if x gets smaller, it's getting close to the parabola. So this thing in red is your parabola. That's an asymptote. That's what we call a parabolic asymptote, so you can have that. Okay, so that's what it would look like. Now, you guys don't need to draw that graph. I mainly just want you to see that and kind of what would happen. So the reason it's a parabola is because if you look at the beginning of the problem, the degree of the top is 5. The degree of the bottom is 3. What's the difference between 5 and 3? 2. Therefore, it's a parabola. If the difference was 3, what would it be? It'd be more like a cubic and so forth. So asymptotes can be different types of polynomial functions. They're not always lines, so that's how that goes. Mainly in that problem, I was just wanting you to see that, okay? Does that make any sense to you? At least somewhat, okay? All right, so really the best things in this section to make sure you study are the first three examples where you do rational functions with a sign chart, because you'll be doing that on your written assignment, and then just know how to do an oblique asymptote. The last two examples, the graphs are more what you're going to do in technology, okay? All right, so I'll wrap this up. If you got your written assignment, since Eric's not here, I need to take those and work on those and see if I can get those marked before Wednesday. So who came in today? What was the person's name? Somebody came in, right? Okay, what? Oh, okay. Eric told me, but I couldn't remember who it was going to be.